Welcome back from spring break, grade 12 students. This is Mr. Al here with a lesson to get you going on a new topic now that you're back at school. I should still be in Costa Rica enjoying the sun, but you guys get the pleasure of continuing to code. I'm a little bit jealous, but not fully jealous. So let's dive right on in. In this lesson, we're going to be covering something called exception handling. And here's what we're trying to learn how to deal with. In my program here, there can be times where when I try and get some functionality up and running, I can have some things go wrong. Let's create a scanner. System.in, and import my scanner. And cool. Now with my scanner, I should be able to grab some information from the user. I'm going to say int input equals scan next int. So I want to get an integer from the user. And you know what? Just to be thorough, I'm going to go, please type in an integer number so that my user knows exactly what I'm looking for. Now when I run my file here, I can type in the number 1 and the program's complete. A nice simple program that gets the input successfully. However, I have an issue. What happens if I go, oh, the number 1, and I try and type it in? Something called an exception pops up. Now that we are thinking about exceptions, I want you to be even more mindful than you might have been previously about exactly what pops up when this stuff happens. And here we see something called an input mismatch exception. I'm actually going to copy this text right here for a reason we'll see very shortly. But the problem, what's going on in Java, is that this error of a different type of data, different variable type than I was looking for. I wanted an integer, but I got sent a string. So I could consider maybe adding in a bunch of conditions to be able to, when I take in the input, see what kind of information that I get and then convert it to all these different states. But in this case, I want to guarantee, I want to say I want an integer as my input directly, and I'm not going to take anything else. So the first thing we're going to do is add on the layer that helps the program not crash. And so we're going to construct something called a catch try block. Or I guess the right way to say it is a try catch block. And here's how I'm going to structure it. I'm going to put the term try, and then this is something that you can decide your stylistic preference of. Some people will, like to catch after here. Some people like to throw catch on, kind of add it onto the line there. I think this looks kind of nice. I think we'll go with this for now. And I also have some information that I need to catch. And in here, I'm going to paste my input mismatch exception. And one thing that we'll see here is that it says cannot find symbol. I actually have to import this exception. Notice I Control-Shift-I, import from my utilities library, the input mismatch exception. There's some built-in functionality to recognize what's going on here that will help me report this error. So here's my basic structure for dealing with exceptions. I'm going to try to do something, and then I'm going to make my program aware that it might need to catch some kind of an exception. Here's how we might metaphorically think about this. Think of a game where, so that's my baby in the background. Let's see if he's quiet enough while I'm doing this. Hello. Back to the lesson. We're going to try to do something. And in my metaphor, I'm going to try and throw a ball to someone else that I'm playing with. And the game's rules are as such. If the ball is ever dropped or touches the ground, it's game over and the program crashes. So whatever I try, it needs to be caught successfully. In my program, if nothing goes wrong, an example of that would be I type in an integer. That is an easy throw. No problems, nothing wrong with it. It's going to be caught and done. But if I type in something incorrect, this is like I have a bad throw. Maybe there's a gust of wind that blows the ball off course. Maybe the sun peeks through the clouds at the wrong moment and it blinds the person who's trying to catch it. Suddenly, it's going to be much more difficult to catch, and so the ball is missed and the game is over. What we want to do is create functionality that's able to kind of step in like a third party and goes, oh, you're missing it. I'm going to rush over and help catch it for you. And then we'll be able to kind of recover the play from there and maybe keep our program running without crashing. So we're going to try something, and then I'm going to create this really helpful buddy who's going to come in and catch this error. When we're thinking about what's actually going on in our virtual environment, try is the logic that's proceeding, and as soon as an error happens, it's going to actually throw something called, the term actually uses throw, legitimately within the program here. It's going to throw an error to Java running in the background, the virtual environment, to deal with. But if we don't overtly state we want to deal with it, then Java's going to receive it, and then it's going to go, don't know what you want me to do with this. It breaks the flow of logic, and the program crashes. But if I have something catch it for me, some functionality that will help deal with the problem, then my program doesn't have to crash, because Java goes, okay, this logic didn't work out. I'm going to do whatever you say here, and we'll work from there. So what am I going to try? I'm going to just define an input out here, and I'm going to say I want input to equal, actually I'll just cut and paste this to save some typing time, to scan the next int. And this input mismatch exception, the way that this works is that it looks if what I'm expecting to come in is different than what actually comes in. And then it's going to know, okay, this is a scenario I can deal with. So there's a few ways I can deal with this. The first one will be the simplest one. I'm going to just say to print out E. You'll have noticed, hopefully, that I created this little E beside it. Basically, this is like an object. It's an input mismatch exception object called E. I'm just going to print out whatever E is if it catches an error. So if it works out, catch will never be run. So we'll see. Let's first just run this successfully. And nothing's changed from original program. But where we see this get much more helpful, I type in 1, and it's going to go, Java util input mismatch exception is reporting that there was an error. Notice, the program ended because my logic is finished, but it didn't crash. It actually finished processing. And let me show you a clear example of this. If I type in the text success here, remember initially we had scan next int here. Let's add the extra line here. So I'm going to initially try and gather in something, and if I go 1, program crashes. But if I remove this and I run the gathering of the int inside the exception, and I type in the wrong input, my program still finishes processing. The catch allows it to kind of deal with the mistake and not crash, which is awesome. So on kind of a lower level, what this allows us to do is to avoid our program crashing whenever we suspect maybe the user isn't paying attention or maybe they accidentally typo. And in other situations, we'll see some of the other issues that can occur. I'll introduce you to a couple more of them in a couple minutes here. But first, let's get to the next level of where this gets really useful and really helpful. What's kind of useless about this so far is that I want this integer. I want it to succeed. So if I type in the wrong input, it just says input mismatch exception, and then it's over and I didn't get what I wanted. So I want to force the user to actually type in what I want. And to do that, I'm going to use a loop. So I'm going to define a Boolean. For now, I'm going to call this got input. I'm going to set it to false. So got input is going to be my controller for when I got the information that I'm looking for. And what I'm going to do is I'm going to put a loop around this. I'm going to say while not got input, while I haven't got the input I want. And then I'm going to move my try catch block inside. Oh, thanks for messing up my spacing there. All right, that looks better. So while I don't have the input that I want, keep on trying to get it. If I get the wrong input, catch the exception and tell me. But I'm going to think about how this loop is actually going to work. Because right now it's going to loop forever because got input never changes back. The right space to break this loop is right below where we try to gather the input, where I'm going to say got input equals true. Here's how Java is going to process this, and make sure you pay careful attention and rewind if you need to have me go over this a second time. I'm going to try to get the input. Right here is where I try and get it. If it succeeds, then it processes the next line, which says got input is true. If it succeeded, it means it didn't need to catch the exception, so this doesn't need to be run at all, meaning it reaches the end of the loop, and now our got input is true, breaking the loop cycle. So as soon as we get a proper input, the loop is over. But what happens if we don't have a proper input? Well, right here, we try to get the input. If it's not correct, Java throws an exception, which in the past would have broken our program, but now we catch the type of exception we're expecting here, and we print out to console that this exception happened. Now what happens is it finishes up the loop. It skips this line because this didn't succeed. It won't allow it to move to the next step in logic until this succeeds. But our program didn't crash, we printed out the error, and then we skipped over whatever happened afterwards. But since we're still in the loop, it's going to try again. And just to make things really clear, I'm actually going to move this statement inside. And let's see what happens here. Please type in an integer number, 1. And right now, we have an input mismatch exception looping forever. So let me close off this infinite loop, and let's take a look back at what might have happened inside of our loop here.